Hello, good evening everyone. So today we are gonna do good evening. Is it audible to all? Is everything fair? So just give me a few minutes and let me share the link with others so that they can join. Sorry. Is it audible? Can you make it confirm please? Is everything fair? Hello. Is it audible? Yeah, yes it's fair now. We will just wait for 1 or 2 minutes so that other people can join the lecture. Good evening everyone. So after a long break, we are having this session of Riemann integration as in continuation of the real analysis. So okay, fair. Let me discuss the integration, Riemann integration here. Okay, so the basic idea behind this Riemann integration is fair. Yes. So our topic is Riemann integrations. Okay, basically this is called as integration of bounded functions on R. Right. Thing is, when you start studying about integration, in that case, the basics, the you can say the fundamental is the Riemann integration, and what you have been doing from your 11th standard, that is basically application of that. Means when a function is Riemann integration, then you talk about the integrability. Fair. Riemann integration is the basis of the integration itself. So let's talk about if you talk this Riemann integration here, you need to know about partition of a set. Okay, what does it mean by partition of a set? For example, if you want to check whether a to b f of x dx, that is integrable, and what you are like basically trying to check whether that is Riemann integrable or not. Fair. So होता क्या है, what happens here is obviously f of x is a bounded function. Basic idea is when you talk about integration, ध्यान से देखेंगे, the basic idea behind this is if you talk about integration, basically it is the summation or infinite summation. Somewhere it represents like this. For example, suppose that if you talk about you are integrating 2 to 3 f of x dx. So what you can do, my dear fellows, suppose that you don't know what, like for example, if you have to integrate like this. At this point of time, what the knowledge you carry that it will become x cube by 3 and you will apply the lower limit and upper limits, right? But that is the highest part of integration. Basic idea from where it started. That is the Riemann integration. So what actually you do a partition. What? Let's say we have the interval of integration as 2 to 3. So what you do, let's do a partition of the interval 2 to 3 with the interval length, subinterval actually, as for example 0.1. So what does it mean, my dear fellows? You start from 2 to 2.01, 2.01 say 2.02. You keep on proceeding like this. Basically, you go, for example, 2.93. So what is the basic idea here? ध्यान से समझिए इस चीज को. What is the basic idea, my dear fellows? अभी देखिएगा. Suppose that if I talk about कि what is happening with f of x in this interval, what is happening with f of x in this interval and in these interval, means how f of x is behaving in these specific intervals. That is the point of interest at this point of time. Okay, suppose that, देखिए ध्यान से, for example, let if, ध्यान से देखिएगा, suppose that I call it as m1 and small m1 and capital M1, here m2 and capital M2, and let's say here it is m10 and small m10. What I call it, it is the lower bound and it is the upper bound. किसका lower bound और upper bound? Of f of x in this interval. What you said? Suppose that small m1 is the lower bound of the function f of x in this particular interval. Capital M1 is the upper bound of the function f of x in this particular interval. So what the basic idea here is, you basically, ध्यान से देखिएगा, you do m1 into length of the first interval plus m2 into, ध्यान से देखिए इस चीज को, length of the second interval plus m10 into length of the 10th interval. Here you take upper bound and you Right. What happens here is, my dear fellows, you have considered the lower bounds in each subinterval, upper bounds in each subinterval. Fair. You have calculated these values, let's say I1 and I2. ध्यान से देखिएगा. What happens if this I1 and I2, if you take the summation, I1 happens to be equal to I2, and let's say you call this as the partition P. In partition P, then you say A to B x square dx or fx dx is Riemann integrable in the interval 2 to 3. If this happens, if it happens to be like this, then you proceed and you think like this here. तो बेसिक आइडिया क्या होता है रीमान इंटीग्रेशन के पीछे? यू जस्ट डू पार्टीशंस एंड यू कंसीडर द लोअर बाउंड्स एंड अपर बाउंड्स. ओके. इन द सेम सिनेरियो, इस पूरे रीमान इंटीग्रेशन के अंदर में यू विल हैव द फर्स्ट पार्ट इज लाइक दिस, you consider lower bounds and upper bounds. The other part is the other part is you consider, ध्यान से देखिएगा, let's say f of t1 into delta x1, f of t2 into delta x2 plus f of tn into delta xn, where f of ti is the value of f of x at a point ti in, let's say, xi minus 1 से xi के बीच में you have taken a point ti. So here within the like starting 10 to 12 minutes, what I am trying to do is I am trying to give you a rough idea कि what actually you do in the Riemann integration. In one way, you took a partition and you focused on the lower bounds and upper bounds. In other way, what you do not focus on the lower bounds and upper bounds only. You focus on the values of the function within that particular subinterval of that partition. Partition किसका? Limits of integration वाला जो interval है उसका partition. Here you land up with the lower sums and upper sums. In both of the methods, you got it as the key. It is something like lower sums, it is something like upper sum. And when you refine, you do the like very infinitesimally small partitions, then you get these lower sums and upper sums equal. You say the given integration is Riemann integrable, otherwise you say it is not to be. So I hope the picture will be crystal clear for you कि what actually the brainstorming for the topic Riemann integration. That Baki, I guess the information is not conveyed properly today, so people are not like there. Although in the group they were asking about when the classes will be happen. Okay. So what I am feeling is I should not stretch the class more here because otherwise it will be of no use. आप चाहे तो इसको नोट कर सकते हैं. एक बार इसको लिख लीजिए. Whoever attending the lecture. नोट हो जाएगा तो बता देंगे. If I have noted, please do let me know. Is everything visible, right? What is the doubt? Same question, both part. Just wait a minute. Abhi, I have just given a rough idea what actually you do in the Riemann integration. You just note down the things. Let me give further examples. You will get the idea. More clarity. With the more clarity. Okay, so let's have few examples over here. अच्छा, पहले तो हम इसको वो लिख देते हैं लोअर सम नंबर्स. Here, UPF, that is called the upper sum of F in the partition P. Okay, LPF, that is called the lower sum of F in the partition P. Fair? For example, if someone asks, so that a constant function f of x equals to k is Riemann integrable. ठीक. So how we would like to answer? देखो, I have already told you Riemann integration is the basic idea behind the integration. Okay. So whatever the limits of integrations are, you just do the partition of limit of integration. You just try to find out what are the lower bounds and what are the upper bounds in each subinterval of that partition. Fair it is? कोई दिक्कत? चलो. So what the idea is, let's divide this interval. So if you call it as lower sum, so this will be small k1 into delta x1 plus small k2 into delta x2 plus small kn into delta xn. If you talk about the upper sum, let's say k1 is the upper bound in the subinterval with the length delta x1, k2, and that is kn. For example, if you talk about this k1, k2, kn and you ध्यान से देखिएगा, since your function is what? It is a constant function, so it has the lower bound as small k. If you have taken the lower bound as small k here, sorry, the function का value, तो constant function है, उसका value तो हर सब interval पे वही दिखाई देगा, the same value will be reflected. So this will be written as small k into delta x1, small k into delta x2 plus small k into delta xn. So that is small k into b minus a, right? Similarly, this will be looking like k into delta x1 plus k into delta x2 plus k into delta xn. So if you take out k as common, this will become, so ultimately it turns out to be again k into b minus a. So from 1 and 2 gives lower sum in the partition P is equal to upper sum. So you say a to b k dx is Riemann integrable. Fair? Just to have the more clear picture over these things, we can discuss the next example here. For example, let's consider f of x equals, it is 0 when x is a rational number, and let's say it is when x belongs to irrational. Let me check that. Fair. Then, so that f of x is not Riemann integrable over any interval. Can you try to think over this? Abhi, if you observe, if you take any partition P here of the limits of integration, what will happen? देखिए, if you talk about upper sums, so obviously it will become like, क्योंकि upper bound is 1, right? So this will be 1 into, let's say, b minus a. If you talk about lower sums, so the lower bounds for each subinter will be 0. So this can be written as, so what do you say? This clearly implies that the upper sum is not equals to the lower sum. So the thing is true, right? Check it out, please. So these are the two examples which can give you some more clarity over the things which we have been discussing here. What is partition, what is the lower bound, what is the upper bound, kind of stuff. Please note it down. नोट कर लेंगे प्लीज. Okay. So what is Riemann integration में the other part is, as here we have considered the lower bounds and upper bounds. Suppose that in different partitions, let's say P is a partition, okay, and what you do is you just take like into consideration the value of the function at points in that subinterval. So what you do here, let P be a partition of the interval A to B, okay, like x naught say x1, x1 say x2, xi minus 1 say xi, xn minus 1 say xn, that is B itself. Here x0 is A itself. Right. So मान लो यहां पर ये है. अभी आपने क्या किया? Let if we denote, ध्यान से देखिएगा, mu p, that is the maximum value of delta xi. So here whatever the maximum length of any subinterval in this particular, delta xi represents what? Delta xi represents the length of the subinterval xi minus 1 से xi for example. Okay. अब इन सारे सब इंटरवल्स की लेंथ में से जो मैक्सिमम लेंथ है, लेट्स से यू हैव गिवन दैट यू हैव रिप्रेजेंटेड दैट बाय द सिंबल mu p. Now we will have two different terminologies here. Let me introduce those as just give me 2 minutes please. Limit of sums. Okay. So when you talk about limit of sums, you will have two terms here. SPF, that is given by summation I going from 1 to n f at pi into delta xi. And let's say you have the other thing is LPF. Okay, so that is called the Riemann sum. Okay, LPF you denote it by I going from 1 to n. The same thing which we have done in the previous representation. Similarly, you can, oh, sorry, okay, इसको लेते हैं. It will give the more picture, better picture here. अभी आप देखिए आप करते क्या है यहाँ पर. बेसिकली यू ट्राई टू डू पीछे द प्रीवियस डिस्कशन विल itself be indicating to you कि what actually you do in each of the sub interval you try to get the like function value into that length of sub interval. अब आप इसका you just take try out different partitions here and you just keep on working with that. Here, if you get this Riemann sum, अब ये Riemann sum क्या होगा? You have taken out the upper sum, you have taken out the lower sum. But here in this case, you did not consider lower bounds and upper bounds, but you consider the value of the function at that. Now, if this exists finitely, what you will say? This will imply whatever the integration you have given here, that is the Riemann integrable. Okay, so that is the second category of questions here. Abhi, what is happening here? Good evening. As I also I shared the information within the group itself around 12 or 1 p.m. I guess. Still, people are not turning up because there is a long gap here. Riemann integration के लिए what I am deciding here is कि अभी अगर पूरा का पूरा हम डिस्कशन यहाँ पे करते हैं so it will not be good because वो मेरा ही fault है for a long gap here. अभी what I do is persons who are attending here मलिक अरोड़ा का जैसे कि हम रियल एनालिसिस कर रहे थे so I have suggested Malik Arora for real sequences chapter, convergence, uniform convergence chapter, and here in the Riemann integration as well. So there is a PDF I will share in the group itself. Malik Arora का Riemann integration में यही दो पॉइंट्स पर सारी की सारी स्टोरी मूव करेगा. अभी what I suggest you guys to go through that PDF, try to solve those examples. Don't be irritated here. Listen to me because जब सारे स्टूडेंट्स नहीं होते हैं तो फिर वापस से मेरे को ऐसा लगता है कि यार अभी कंटिन्यू करना है या नहीं करना है लाइक दैट, क्योंकि अभी उतना टाइम ऑलरेडी मेरे पास नहीं होता है कि मैं चीजों को बार-बार करूंगा इधर. तो what I suggest you, please go through that PDF and do let me know if you want another session on Riemann integration. I'll definitely come out with that. But मैं इतना suggest करूंगा, I will suggest you only Riemann integration जो chapter है मलिक अरोड़ा में, you just solve examples of that chapter. It is more than sufficient for your CSE and forest services exam. If you you just go through that PDF, if you just come across any of the doubt, do let me know. I will definitely consider that. But things is I have to stop the lecture today here itself because I'm getting the things कि अभी उधर पे what is someone is commenting. Let me just check the comment. एक सेकंड दीजिए, let me check it. कनिष्क जोशी सर थोड़ा वॉइस भी इंक्रीज करो, मैंने फुल कर रखा है फिर भी कम सुनाई दे रहा है. वॉइस का यार मेरे को पता नहीं, मैंने ध्यान नहीं दिया. ठीक है, I'll check कनिष्क. पर अभी क्या है ना कि मतलब आज के सेशन में मेरे को भी, मैं सुबह 8 बजे से लेक्चर ले रहा हूँ, तो उतना एनर्जी नहीं आ रहा है ऑनेस्टली स्पीकिंग. ठीक है. तो अभी आई एम सॉरी फॉर टुडेज दिस इंटरप्शन, बिकॉज आई वाज ट्राइंग कि यार हो जाएगा करके, बट वो एनर्जी लेवल नहीं आ पा रहा है. तो मैंने एक जस्ट जिस्ट देने की कोशिश की है. यू जस्ट गो थ्रू द पीडीएफ. I will surely discuss if you come across any of the doubts there for the Riemann integration. आज के लेक्चर को आई वोंट बी कॉलिंग इट एज कंप्लीट लेक्चर. जस्ट से कि एक लेक्चर ने स्टार्ट किया था बट आई कुडंट कंप्लीट दैट. व्हाट इज शुभम चौबे? हाँ, आई विल ट्राई. एक्चुअली आज सुबह 8 बजे से लेक्चर ले रहा था, फिर मतलब रात को हिम्मत नहीं पड़ रही थी मेरी. फिर भी आई थॉट कि यार शेयर कर दिया है अभी इंफॉर्मेशन, तो मेरे को ट्राई करना चाहिए. बट उतना इंथ्यू नहीं आ पा रहा है जो नॉर्मली लेक्चर्स में इंथ्यू होता है मेरे को. तो मेरे को खुद को भी बहुत अच्छा फील नहीं हो रहा है. तो प्लीज गिव मी सम टाइम. आई विल डेफिनेटली अरेंज like another session on the Riemann integration itself. Sorry for today's. Okay. And please don't consider this lecture as some parameter of assessment. ठीक. Thank you.